So what does this all turn out to be? 1/2 plus C is 3. So C, 3 is 6/2. Minus 1/2 is 5/2. And so my particular solution is minus 1/2 cosine 2x divided by sine x plus 5/2 sine x. Yes, sir?
Would you get a different constant if you solved it the other way?
Yes, you would. But you would get it, if you do it the other way, you get your result. It isn't going to look like this, right?
No.
But they'll be the same. They'll be equivalent via trigonometric identities.
Okay.
You see, if you do it this way, you're going to wind up with what? Sine squared x over 2, or actually sine squared x.
For sine x,
Right.
That cancel.
And there's a formula, a relation between sine squared x and cosine 2x. Everybody should tell me what that is. What's the relation between cosine 2x and sine squared x?
Sine squared minus sin squared equals double angle of cosine.
I couldn't understand a word you said.
No,
No, that's okay.
minus sin.
I heard it, but yeah, all right. Because I want to say it. Cosine 2x is 1 minus 2 sine squared x. Double angle formulas. For sine 2x is 2 sine x cosine x. For cosine 2x, there are 3 formulas. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. I'm saying that to dredge up your memory about the trigonometric identities. On my web page, I have a table, it's called the table of integrals. But I believe at the bottom of that, I believe at the bottom of that has a bunch of basic trigonometric identities. I'll check it to make sure. Okay. So, one more example. Find the general solution of this. It's linear. It's already in standard form. So I multiply by e to the integral 2x dx, which is e to the x squared. We get e to the x squared y prime, 2x e to the x squared y equals 2e to the x squared tangent x. The left side we now know is x squared y prime, e to the x squared y prime, 2e to the x squared tangent x. So e to the x squared y is the integral. 2e to the x squared tangent x dx plus c. And that's it. Nobody can integrate e to the x squared tangent x. Doesn't have any antiderivative. In calculus 1 and 2, you spend a lot of time doing integrals. But in fact, if I just sat down and dreamed up a function, no one can integrate it. There's very few functions you can actually integrate. They have to be very special. And of course, you spend a lot of time in calculus 1 and 2 looking at the special ones. But, you know, I just wrote down, that's a very simple differential equation. Nothing hard about 2x or tangent x, standard functions. But we arrive at this integral, no one can do that. Right? Can't be done. So you just leave it that way. That's the answer. Sometimes you get an integral which you can't do. Now, on quizzes and exams, we try to avoid that. But there's always a none of the above option in case we screw up. On the exam, we haven't failed yet. When you have to do an integration, it's one you should be able to do. Okay. So, where does the term linear come from? So I'll try to explain where the term comes from. And after we do section 2.2, that is move on to chapter 3 and 4 and 5 and 6, everything is linear. So the idea of being linear is fundamental to this whole course. What does linear mean? Well, let me try to explain it this way. Let D be a symbol for taking the derivative with respect to x. Okay? So, for example, d of x squared means the derivative of x squared. That's 2x, right? D of cosine 2x is minus 2 sine 2x. Differentiation is an operation, right? It's an operation. It's actually, you can think of it as a function. This operation takes x squared to 2x. It takes cosine 2x to minus 2 sine 2x. It's a function. But in mathematics, a function whose domain is functions is called an operator. Differentiation takes functions to functions, right? You give me a function, its derivative is another function. So it's a differentiation is a function. Mapping functions to functions. Such a thing is called an operator. Now you do know that the derivative of f plus g, the derivative of a sum is the sum of the derivatives, right? Fundamental property. Derivative of sum of the derivatives. Derivative of a constant times a function is simply that constant times the derivative of the function. So this operation of differentiation has these two properties. Derivative of the sum of the derivative. Derivative of constant times function, constant times derivative of the function. Integration has these two properties, right? Integration, excuse me. Integration takes functions to functions. Right? Integral of x squared, x cubed over 3, plus a constant. The integral of a sum is the sum of the integrals. The integral of a constant times a function is the constant times the integral of a function. You can take constants outside the integral side. So integration has these two properties. If you look at a linear differential equation, y prime plus p of x y equal q of x, and focus on the left-hand side, this is an operation, okay? I am going to take an arbitrary function, multiply it by p, then take its derivative and add it up. So I'm going to start with some function, multiply it by p, then take its derivative, add those two things. That produces another function. So L here, this left-hand side, is an operation. And I took an example. Look at the linear differential equation, y prime 2 over xy equal 4 of x. Look at the left-hand side. Call it L. What is L of 2x cubed plus x? x prime plus 2 over x times 2x cubed plus x, which is the derivative of 2x cubed, 6x squared plus 1, plus 4x squared plus 2. So L took this function to this function. What is L of e to the 3x? It's e to the 3x prime plus 2 over x times e to the 3x, which is 3e to the 3x plus 2e to the 3x divided by x. L of this is this, and so on. It's easy to show that L of a sum, and here I'm showing it, L of y1 plus y2, y1 plus y2 prime, plus p times y1 plus y2. The derivative of y1 plus y2, y1 prime plus y2 prime, py1, py2. Rearrange the terms. L of y1 plus y2, L of y1 plus L of y2. L of a constant times y is that constant times L of y. So here's the deal. Any operation that has these two properties is a linear operation. Differentiation is linear. Integration is linear. It's a shame that you didn't identify that in calculus.